This purple planet you are currently looking at has iodine-rich hexane as its liquid. But can this planet even sustain hexane in liquid form? I wanted to make sure the planets generated in my game had a liquid that was feasible based on the planet's attributes. Of course, you factor in the temperature of the planet, because if you take a planet that's 200 degrees Celsius, and you take water, which has a boiling point of 100 degrees, that planet can't have water, right? But these planets also have different atmospheric pressures. We can see how pressure plays a role when you take a look at a phase diagram. As you can see right here, the water would be a gas, but if we increase the pressure and the temperature remains the same, it then becomes a liquid. So, if we take that 200 degree planet, but it has an atmospheric pressure of around 16 times Earth's, it could sustain water. This made finding each liquid's true boiling point a little bit more complicated. To solve this, I used this fancy little equation called that. Using that equation, I could solve for T2, or the adjusted boiling point. With my data sheet of liquids, I could plug the data of each liquid into the variables of the equation and compare the average temperature of the planet to the freezing point and the adjusted boiling point solved for. If the planet's temperature falls within that range, I add it to a list of possible liquids for that planet. Then, a random one is selected. That way, any liquid chosen is actually plausible for that planet.